I'm Dr. Paul Houle. Thanks for coming over to this video where I'm going to present some of the health issues that can be treated by builders during the construction phase of homes. These techniques are easy to do and pretty inexpensive. So let's begin with what we can do with these radon issues in new construction. First, let me tell you what the health risks are before we get into the details of the radon issue. And you can see here that there are 21,000 deaths per year attributed to radon causing lung cancer. It is the second leading cause of lung cancer in America. And we all know what the first cause is. That's simply smoking. And interestingly enough, Pennsylvania is one of the most problematic states in the entire country. It has a tremendous amount of radon in it. And in fact, the radon problem was first discovered here in Pennsylvania. Here I'm showing you that the radon is producing about 21,000 deaths per year. And that's all due to lung cancer. And I'm comparing it to the number of deaths due to drunk driving, which is a little over 15,000, drowning and fires and air transportation you can see here. So of those that I've listed, radon causes the greatest number of deaths. I put this here because it's a little bit surprising to me when I first saw it, and that is that it's more than the number of deaths due to drunk driving. I really thought drunk driving would be far more, but that is not the case. Deaths due to lung cancer due solely to radon are a significant health risk in the United States. In particular, in the U.S., or rather in Pennsylvania, 40%, you'll notice here, 40% of all the test results are producing values greater than or equal to 4 picocuries per liter. Now, I wouldn't worry about the unit. The 4 is important, though. That is called the action level in the United States. And by that, we simply mean that the EPA is stating that if the radon measurement is discovered in a home to be greater than or equal to 4, you really should do something about it. And you'll notice here 23% of the test results are between 4 and 10, 5% between 20 and 50, and roughly 0.5% of values greater than 100. Those are pretty big numbers. Now, the 0.5% seems like a pretty small number. Percentage-wise, that is a small value. However, there's been significantly more than 1 million homes tested in Pennsylvania. So this comes out to be more than 5,000 homes that have radon concentrations greater than 100. And in fact, there's been a number of homes found in Pennsylvania where the radon concentrations has been in the thousands. So those values are very high. There is no scientific organization that does not believe that radon isn't a health risk. Let me put that all in the positives. Everybody believes that radon causes health risk, that it causes lung cancer, that it is a deadly carcinogen. And in fact, while you're watching this video, which will run about a half an hour, one person in the U.S. will die from lung cancer due to radon. If you take that 21,000 people per year, that's about one person every half hour. Now let's talk about what radon is. First of all, it's a soil gas, and this is important to know. It's generated in the earth, and it's a very slippery gas, so it can percolate up through the earth and into the atmosphere. Now, if you put a building on top of where the radon gas is percolating up, then it has the opportunity to get into the building, and that's how it gets in. Now, it's pervasive, as you can see in the second bullet here. It's pervasive in the sense you find it everywhere. We have looked in lots of different pieces of land, and in all cases, we found radon concentrations. Now, in some areas, you find more than in other areas, of course. And depending on the construct of the building, that will determine how much of that radon can get into the building. No human senses can detect it, and so you can't see it or smell it or touch it or feel it or anything like that. So you need to have other kinds of equipment in order to measure this radioactive gas. And it's radioactive, and that's why it's dangerous. It's radioactive so that when you inhale it, it decays, and while it decays, it can do damage to your lungs. Here's EPA's map for Pennsylvania. EPA published a map years ago for all the states, for the country as a whole, and this is Pennsylvania's map. And where the red counties are located, that's where the radon concentrations are expected to be the highest, and where the orange is not quite so high, and where the yellow is, that's this little guy down here, Philadelphia alone, that one is expected to have the lowest radon concentrations. Now, these are just average values. They represent average values. This means that if you're going to have an average in a given county of 2, let's say, then you're probably going to have some 1s, some 1.5s, and you're going to have some 10s and 20s. And so you need to test the house to see if radon's in it. Because just because the average is low doesn't mean that the house you're dealing with is also going to be low. And so we have a saying in the radon industry, the only way to know is to test. And that's really pretty essential. Now, you as a builder can make a significant difference. And I'm not suggesting that I'm a builder or a contractor, but I do understand some things about what you're doing as a contractor and a builder. Most of you, if not all of you, are really trying to build a quality home, something in which you can take a certain pride and say that I built that house. Now, we're urging you to add some additional safety to it, to do a few things during the construction phase which will diminish the amount of radon that can get into the building. And should it get into the building, even after you've taken these initial steps, you can easily activate your radon system to eliminate the radon problem. You can make it a custom feature for your properties. When you get people coming in and they want you to build a home, you can say, well, would you like the radon resistant features put in as well during the construction period? And it can give you an edge on the market. You can provide a brochure on your radon resistant features along with all your other handouts that you would have to prospective customers. Now, there are 4 main factors which control how the radon gets into a building. Of course, how much radon is in the ground, and I've listed that here as how much uranium is in the soil. And the reason for that is when uranium decays, it decays into a bunch of things, one of which is radon. And radon is the gas. And so the gas has the opportunity to drift around in the soil and be driven out. Remember, the soil gas pressures are a little bit higher than the atmospheric pressure. And so the soil gas is actually being pressured out into the atmosphere. Furthermore, as you're already aware, the air pressure in the home is typically lower than the atmospheric pressure outside by a little bit. And so from that, we can easily see that the air pressure in the home is less than the soil gas pressure. And so radon is driven into the home by the fact that the soil gas pressure is higher than the air pressure in the home. Now, the steps that I'm going to point out to you, they're really very easy, and they're quite inexpensive to execute. We're going to be talking about putting in what's called a passive radon mitigation system, such that if it turns out that the house has a radon problem, we can activate it easily and get the radon concentration down. And there are certain other advantages you get from this, and that is, as you can see here in this last bullet, you get an additional decrease of moisture, which cuts down on mold, mildew, and any other soil gas that's in the area that's beneath the house will get drawn in and taken out before it has a chance to get into the house. Some of your building codes may already reflect on what steps need to be taken to put in radon mitigation systems. And if that's the case, you probably already know this, where it is in the codes. And if you have a local code that stipulates how you to do radon mitigation systems, then you need to follow those codes. If you don't, you can use this document, which is EPA's document titled Building Radon Out. This is a great book. It's not very big. It's well written. It's got lots of pictures in it so you can see what's going on, what the authors are talking about. And I referenced this in one of the very last slides, so you can look it up on the net if you want, and then print it out at your leisure if you want to read up about it. And the nice thing, one of the nice things I like about this manual is that if your house is on a crawl space, it tells you, well, this is the way you do it. If it's on a slab, it tells you, well, this is the way you do it. If it's on a basement, it tells you, this is the way you do it. So it gives you lots of direction on how these things need to be done. It is way cheaper to put in a passive system during construction. All the walls are open. If you're going to run pipe up through the building, that's obviously much easier to do and looks much better if you do it during the construction phase. You can hide it in the walls, you can hide it in other closets, etc. Costs sometimes about $100, sometimes a little less, sometimes a little more than $100, but that's the order. That's a representative number. Whereas if you're going to do a mitigation system in radon, say the house is already built and now you've got to do the entire mitigation system, cost is going to cost you around $800 and up. And then if you need to, what I'm going to be talking about here is encouraging you to put in a passive system. And then if you need to upgrade it, really all that requires is putting in an exhaust fan in the piping and getting that running. And I'll show you how that works here in just a minute. And that's tremendously effective in getting the radon concentration below the action level of 4. Now you can see here just a few notes about what radon is, a little more detail about radon. You can see that it's measured in picocuries per liter. It's a crummy unit, but it's the unit that's used in the US, and so that's what we have. I won't be saying that unit. I'll be talking about values of 4, 5, 10, 20. I'll always mean picocuries per liter. Here you see the outside ear. If you make a measurement outside, just go outside the building you're sitting in right now. If you go outside and make a measurement in the ear, it's going to come in around 0.4. The average inside ear is about 1.3. These are values clearly below the action level. And as I mentioned a moment ago, some Pennsylvania homes have been found in the thousands, in the many thousands. Now, how's it get into the building? I think you can already figure that out. It's a soil gas. It's going to get into the building through any cracks or crevices that are available. It's an incredibly slippery gas. It's actually called an inert gas, meaning that it doesn't interact with anything. So it doesn't get compounded with some other atoms like hydrogen. You mix it with oxygen, you can get water, you can get all kinds of other things. But radon is just radon. And you can see here in this slide, I've listed a bunch of the ways it can get in. And I think I can show you a better view of this picture here. And what I'm showing here is you can see that if there are any cracks in the slab, in this particular case, expansion joints, this conduit, if you have conduit coming into the building, say you're running your plumbing line, it's on a well. Even if it's not on a well, it's got to be a plumbing line somewhere. It comes in probably through the foundation, and that is probably not airtight, and so the radon can get right through that. Lots of ways for the radon to get in. One additional way that radon can get in, as you can see here, I've indicated you can get it in through the water, and that's a distant second from the gas percolating into the house directly from the soil. But if the house is on a well and it's going to draw well water into the house, then the radon that's in the water underground, that radon will be brought into the house along with the water in which the radon is in. And when you turn on the faucets, the water starts coming out, and the radon comes out of the water abruptly, right away. Very much like if you open a soda can and you pop it open, you can hear the gas come out, and that's the carbon dioxide coming right out. Well, that's what happens with the radon. The slightest agitation to the water, and the radon comes right out. Then it becomes a radon and air problem because now you can inhale it. So these are the different ways that the radon can get into the building. And I think by knowing how it gets into the building, you can now quite well figure out how to prevent it from getting into the building. Let me also say that if you're looking at lots, if you've got 100 lots in one area that you're going to develop, and you want to say, well, maybe there's some lots I don't want to develop because if I can find it, there's a lot of radon in some lots and no radon in some other lots. That doesn't work. No matter where you look in the ground, you're going to find some radon. And what will determine how much radon gets into the building is to a large degree a function of the construct of the building, as well as, of course, as the radon in the lot. Now, any design can be mitigated, whether or not you're on a slab, crawl space, a basement, whatever design you have, that can be mitigated. And here's a drawing of what it might look like. And I can get this a little bit bigger for you here, I think, right by doing this. Yes. And now you can see what it might look like. So here's a house that has a basement and a portion of it that's above a crawl space. And the idea here is what we're going to do is we're going to take the gas that's in the soil out through a vent pipe like this and into the atmosphere before it has a chance to get into the house. So what we do is we're going to put a vent pipe. Usually it's going to be a 4-inch plastic pipe. 3 inches permissible, 4 inches is clearly better. And we're going to stick that pipe into the gravel aggregate. And we're going to dig out a little bit of the gravel to leave a little vacant space. And at the end of that pipe, we're going to put in a T and then about 8 feet of perforated pipe, at least 8 feet of perforated pipe. And then the air that's in the aggregate will flow towards this pipe and then up and out through normal venting. Thermosiphoning action is what's going to happen. This is called a passive system. And you can see the other parts here. The other parts of the system, of course, is you have a good gravel aggregate, and that's the way you're going to build a house typically. You're going to have a plastic sheet and then a concrete slab. And this 4-inch pipe needs to be put in beneath the plastic sheet and several inches into the gravel. So you can see this is the way you would do it for a house on a basement. Now, if you had a house that was over a crawl space, what we do is, what you will do, is you put a plastic sheet down over the dirt. This is an unpaved crawl space. Over the dirt, and you put your vent pipe under the plastic and above the dirt. And you put a T, and again, you should put at least 8 feet of perforated pipe. And then the thermosiphoning action will take the radon and out through the roof. Now, this is not always effective. This is called a passive system. And many times this is inadequate to remove the radon from the building. But that's okay, because I'm going to show you how to fix that easily. Now, note also one other thing. As part of the passive system, you're going to put an electrical box up here so that you can wire up an exhaust fan, which we are now going to call a radon fan, and be able to turn it on when the time comes that you might need it. So typically the fan is not put in initially as part of the passive system. The fan's going to cost you $150, $200, and we skip that expense just by making it a passive system first. After all, there are many houses, roughly half the houses that you build will not have a radon problem. And so you will have just this passive system available. But the other half of the houses that you're going to build, they are going to have a radon problem. And for those, you're going to have the system already available such that if the radon concentration in the building turns out to be more than 4, more than the action level, you're going to stick an exhaust fan in here, wire it up to the electrical box, and you're going to get a reduction in the radon such that it'll get below the action level. That is called sub-slab depressurization. It's tremendously effective. There we go. One of the things you're going to have to be careful about is you've got to seal and caulk all the cracks and spaces to prevent radon gas from getting into the building. And you might think, well, geez, if I seal it and caulk it, I can make it airtight and that will stop the radon from getting in, and that's just not true. You can make it seem like it's airtight, but radon's an incredibly tiny item. You could take a ballpoint pen like I have here, and I can put on the tip of that pin trillions of those radon atoms. That's how small they are, of course. And they're slippery because they're inert. They don't interact with anything. And so you may think it's airtight, but trust me, it is not airtight no matter what you do. However, you need to do the sealing and caulking. And let me just get back to that. And the reason for doing the sealing and caulking is the following. If you should put a fan in up here, an exhaust fan, and I'll show you a drawing or two of that. If you put an exhaust fan up here, that's going to lower the pressure down beneath the slab. And of course, the air that's down beneath the slab will get drawn up and out the exhaust pipe. Now, if you have a crack in the concrete slab or an expansion joint that has not been caulked, then what will happen is air from the room will have the tendency to come down into the gravel, because remember, the pressure in the gravel now is going to be low. And that, let me get that back again. And that room air will now be exhausted to the outside. So you'll be taking the air to some degree, some of the air out of the basement and sending that outside, which of course we don't want to do, because then we'll have the expense of the heating loss due to that. Plus, it diminishes the efficiency of taking the radon out from beneath the slab. So sealing and caulking is essential, but it is typically not enough. And then whatever air systems you put into the building, let's say you have a forced hot air heating system, then you want to make sure that the plenums that you build and the ductwork that you establish is pretty airtight, so that you're not drawing air from the basement and drawing it through the rest of the building, etc. So that needs to be done well. Now here's an example of some adequate piping that's put in. Here you see it's put in on the dirt, and I imagine here we're going to see 4 inches of gravel or so put on top of that, and then a sheet of plastic, and then you're going to pour your slab on top of that. And you all know what you're doing with that, way more than I know. Now, what size pipe should you use? Again, you can look at that EPA document, but fundamentally, a 3-inch or 4-inch pipe. 4-inch pipe is far superior to 3-inch pipe, but 3-inch pipe can be considered as adequate. And you need to use perforated pipe, and you cover the pipe with this product called geotextile cloth. And what that will do is it'll stop dirt and other things from clogging the perforations in the pipe and diminishing the effectiveness of the suction along that pipe through the radon. Here's another example where the piping is put along a perimeter. You can see it's beneath the gravel here. And here's just a bigger image of the different parts of the pipe installation. I'll show you each piece separately for just a few seconds. The PVC pipe, you see here's the pipe here going up through the roof, and it's going to exhaust through the roof, of course. And it's going to be down, its bottom's going to be into the gravel and connected to the piping that you will have put in which is perforated and which will allow the radon to come through the gravel into the pipe and be drawn out. Plastic sheeting we're all familiar with. You put that over the gravel. That helps keep the moisture down. Really acts as much as a moisture barrier as it does anything else. And then over here, put the electrical junction box in case you need a radon fan later. If you need an exhaust fan later, that is, if the passive system by itself is not doing the job, then you can just cut this open, put a fan in, and wire it up. You've already got the junction box in place. That makes it neat. It looks good, and it'll be effective. Sealing and caulking we talked about, and the crutch stone you're already aware. They recommend 2B stone. I believe that's pretty much what everybody uses. Here's another image of it, and I can enlarge this for you right here. I think, here we go. Just give you a better shot of that. And you can see here's the pipe that's going up through the wall somehow or hidden. It's easy to hide it during the construction phase. And you'll notice that it's teed off at the bottom. And what's missing in the drawing is you should have at least 8 feet of pipe extending from the suction point, perforated pipe, that would be connected into the T. And you would do that, of course, during the construction phase. And you can see the rest of the parts that we talked about. Now, the last thing, I always say the last thing and then there's something else I want to say, but the last thing is you need to test after you've sold the house and the occupants have been living in it for a little while. And there are lots of ways that you can do the test, but generally the easiest way to do the test, and you can get some cooperation from the homeowner to do this, but you can get a charcoal can, and they run, well, maybe $15 at your local hardware store, and they're so easy to use. This charcoal can here is the way you would buy it. And to activate it, all you do is peel this off, and I stick the label on the bottom so I can find the label again, and you'll leave it out there for 3, 4, 5 days. However many days is permitted, but usually 3, 4, 5 days is about right. And then after that, retrieve it, you put the seal back on, you fill out a form giving the address of the building and the day and time at which it was started and stopped. And that's pretty much it. And you send it to the lab, and within a few days, you'll get the radon result. That's if you want to do a short-term measurement. You may want to do a long-term measurement, and you may want to put a long-term detector in the house, and that would be one of these little alpha track detectors. They're a little bit more expensive, and at least in part for that reason, they're not nearly as popular. But these can be deployed for 90 days, 100 days, a year, if you want. These are ineffective in short deployment periods of less than 90 days. They really have to be deployed for more than 90 days. But I think you will see that the most popular detector type is the charcoal can. So here's a picture of the 2 detector types, and you can see the charcoal cans here, and you can get them in a lot of different places. The can I was showing you here is a 3-inch can. They have 4-inch cans and larger cans, but they all work the same way. They're all charcoal absorbers, and they absorb the gas, and if there's any radon, they will absorb that too. And then the lab will be able to detect the radon because it's radioactive and it gives off these frankly deadly particles. And the alpha track detector works in a similar way. It doesn't have any charcoal in it. It's just a little plastic strip, and it records the decay products from the radon. And this brings us finally to post-testing. Once you've sold the house and people have moved into it and they're established in the house, at that point, the property needs to be tested for radon, which is a really easy thing to do, to see if in fact they are having a radon problem. Now, the easiest way to do that is you take one of these charcoal cans. You can buy them at your local hardware store. And to activate them, all you have to do is you peel off the label on them, and I usually stick it on the bottom so I can find it again later. and deploy it in the home in an appropriate place. And you leave it in there a minimum of 48 hours and typically 3 or 4 days. And then when you're done, you go back and you get it, and you can get some cooperation from the homeowner to deal with this for you. And you put the seal back on it, and then you fill out a form that indicates what the name and address is and what day it was started, what time it was started, that kind of thing. It only takes a minute. And you send it back to the lab, and then the lab will then analyze it and send you the radon concentration back. And you'll know if you have a problem. Now, if a problem does occur, if the concentration's above 4 or equal to 4, then the thing to do is to have an exhaust fan, which is called a radon fan. Have a radon fan put in the building. Now, typically from the constructs, the drawings that you've seen here, you could put it in an attic. In many cases, the radon fan can be put outside. There are lots of ways that you can orient the piping and the fan. But the fan must not be in a livable part of the building, simply because should the fan leak, it will leak large amounts of radon into the building. And so that's all that needs to be done. So post-testing and needs to be done, and after the occupancy. The types of testing you can do, as I mentioned, is the charcoal canister. I also show you here the another kind of detector. It's an alpha track detector, runs more than 90 days. You can't use these typically for less than 90 days. So if you want to do, or the homeowner wants to do a 1-year measurement, he can deploy one of these for a year in the appropriate place in his home. I give you some of the references here. My favorite reference is this first one, Building Radon Out. Several things about it I like. First of all, it's free. And secondly, it's got great drawings and sketches that show you exactly how to do an installation. Another one you can get is, here's another document, Model Standards and Techniques. You can read this for yourself. And that's another excellent reference. Or the American Association of Radon Scientists and Technologists, they have a standard that they're using, which is, here's the abbreviation for it. Now that one they charge for, so that one's not free. But that one also delineates how to do an installation. You may also have these documents already on your bookshelves as to Appendix F in the American Building Codes, or Appendix D in the international codes. And of course, you'll need to check with your codes officer, or you probably already know which code you're supposed to follow. And then just follow whatever code that is. If you need additional guidance, of course, you can call the Pennsylvania DEP. They're a tremendously helpful agency. They're very supportive. If they don't know the answer, they'll look it up for you. They're a great group. Their phone number is 1-800-23-RADON. It's easy to remember. It's 123-RADON with the 800 tucked in there appropriately. And you can see there are one other code here, this last one, that I list for you that may be of some use to you. So fundamentally, the issue is this, that you can, for $100, $200, put in a passive mitigation system. And then if the house turns out to have a radon problem, you can stick an exhaust fan on it and solve the problem. It'll look great. It can be a selling feature for your house, and you're going to help the health of the people who buy houses from you. And so let's do this. Let's save a life today.